you can see example 6.5. Prove by vector method sin of alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. So take x-axis, y-axis, and you see here if we have alpha minus beta means that is both the points you have to take in the first quadrant. If you have alpha plus beta means one point you have to take in the first quadrant and the other point in the fourth quadrant. Okay, so I am taking A and B like this, and you can take OA vector as A cap, OB vector as B cap. Then draw AL and BM perpendicular to x-axis. The angle between x-axis and this OA vector is what? Alpha. So this full angle is alpha. Then the angle between this x-axis and OB vector is beta. Okay. Then the angle between this A and B is alpha minus beta. Okay, this full angle is alpha, this is beta, so this angle between A and B is alpha minus beta. So introduction, how I wrote for the previous sum only I have written. Let A cap equal to A vector and B cap equal to OB vector be the unit vectors which makes angle alpha and beta with the positive x-axis respectively, and draw AL, BM perpendicular to x-axis. So now what you have to write, OA vector you can take, okay, that is A cap. A cap is equal to OA vector, and this OA vector how we can write, OL vector plus LA vector. Okay, OL vector plus LA vector. So it is equal to, I said any point on the unit circle can be written as cos theta comma sin theta, isn't it? So here the angle is alpha. So cos alpha into the direction is I cap. It is along the x-axis plus sin alpha into j cap. So this is our A cap. Now same way you can write B cap. B cap is equal to what? OB vector. It is equal to OB vector. You can write it as OM vector plus MB vector. So OM vector plus MB vector. It is equal to, so same way, this is the x value. Okay, for B the angle is what? Beta. So cos beta I cap plus the next one is sin beta j cap. Here both are in the first quadrant only, so for I cap and j cap you have to put plus. B cap is equal to this one. Now you can find B vector cross A vector. So listen, this concept you have to understand. In dot product, that is when cos is coming, cos A plus B or cos A minus B, we will use a dot product. Dot product means A vector dot B vector is equal to B vector dot A vector. So even if you change the order, no problem. But when sign is there, we will take a cross product. Cross product means A vector cross B vector is not equal to B vector cross A vector. When we interchange, we will get a minus sign, isn't it? So here you see, I am writing the general formula first. A vector cross B vector is equal to, the general formula is modulus of A vector, modulus of B vector, sin theta. Here theta is the angle between A vector and B vector, and the angle should be measured in anti-clockwise direction. Okay. Along with that you have to put n cap. N cap is the unit vector that is perpendicular to both A vector and B vector. So this is the formula. So I am writing here B vector cross A vector, because you see I said no, the angle should be measured in anti-clockwise direction. So B vector is coming first, B cap is coming first. So I am writing here B cap cross A cap. So it is equal to modulus of B cap. You can write A cap cross B cap also, then one minus sign will come. Okay, so modulus of B cap into modulus of A cap into sine of the angle between B cap and A cap is what? Alpha minus beta. So alpha minus beta. Then you have to take the unit vector that is perpendicular to both A vector and B vector. You see this A vector and B vector is in the xy axis, isn't it? So the axis that is perpendicular to xy axis is z axis. There the direction is k cap. So we are writing here k cap. Then we know these two values are 1. So modulus value is 1 because it is a unit vector. So B cap cross A cap can be written as sine of alpha minus beta into k cap. Mark it as equation 1. Then in one more way I am going to find this value B cap cross A cap. It is equal to, how you can find the cross product is, in the first row you have to put I cap, J cap and K cap. Then B cap. B cap means the coefficient of a B cap. So here we have cos beta. So cos beta, then the coefficient of J cap, it is sin beta. No K cap term was there, isn't it? So you have to put 0. Then A cap we have. So take the coefficients of A cap, it is cos alpha, then sin alpha. No K cap term is there, so 0. Now you can expand it. So along the last column I am going to expand it. So K cap alone I will take. It is equal to what? K cap into, leave this first row and last column. So you will get sin alpha cos beta minus cos alpha sin beta. Here we have B cap cross A cap. This is our equation 2. So from equation 1 and 2, we get sin of alpha minus beta into K cap is equal to K cap into sin alpha cos beta minus cos alpha sin beta. Now on both the side you can cancel K cap. So you will get sin of alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. This only you want to prove. Homework. In exercise 6.1, 9th sum and 10th sum, listen, these two sums are similar to this example and the previous example. These 4 sums are very important sums. So when I send the PDF, I will send the PDF for these 2 sums also. For the homework sum, I will send the PDF. You do it by yourself and you can refer that answer if you want.